Okay, so before we continue on the question from iteration number 2, I think all is well, right? Since it's like we looked at most of the things, iteration number 3. Sorry, 2. Okay, so if you find a challenge to iteration number 2, consult, okay? As of now, let's start looking at iteration number 3. Okay, so iteration number 3. Let's check. So iteration number 3, we have there are about 7 questions. Yes, there are 7 questions. So I'll start with the first question. So first question says, for each of the following, the equation f of x has been written in the form, okay, in the form x is equal to gx. Okay, so f of x is equal to 0 has been written in the form x is equal to gx. Determine which one converge to a fixed point in the specified interval. So we have the first question here, A. The equation is given as g of x equal to 5 over x squared plus 2, and then the interval given to us is from 2.5 to okay, now this is so we have to determine which one converge to a fixed point in the specified interval. So if we are using fixed point iteration method. So previously we are looking at bisection method. Okay, so this one is fixed point iteration method. It's another method that is used to solve non-linear equation with one unknown. Okay. So these are non-linear equations, of course, as you can see. So we can use fixed point iteration method also to solve non-linear equations with one unknown. Okay, with one unknown. This one is a better option because it's quicker than bisection method. What do I mean it's quicker? I mean just say, okay, convergence is faster as compared to the other method, the bisection method. Okay. So first to check that there is a fixed point, okay, in the given interval, there are some rules we need to follow first. There are some things we need to check. First of all, the given function, this is g of x, must be continuous, okay? So first of all, it must be continuous. On the given interval, okay? What does this mean? So this means that if you get any value in that interval, you plug it in the function given g of x function, there should be a situation where we have 0 in the denominator, okay? That's what it means. So if you notice here, we have this interval 2.5 to 3. We can substitute any value from this interval, any value of x. Remember that this is an interval. It's not a coordinate like 2, 3. It's an interval. There are infinite numbers between 2.5 and 3, okay? If we pick any number between 2.5 and 3, we substitute in the function here. The function is to be valid. We get back a real number. The only way we can have something like 0 in the denominator, it's when of x equal to 0. Because if we have 0 in the denominator here, then this function becomes discontinuous in the given interval. But you look at the interval here, it doesn't have any 0. So you can pick any value from the interval, this function is to be continuous. So as you can see, this function is actually continuous on the given interval. Okay, so g of x is continuous. Okay, you can make this conclusion by just looking at that. is continuous on that interval, okay? 2.5 to 3, okay? And the other point you need to know to check first is g of x must be bound, okay? Must be bound within the given interval. What does this mean? Okay, so this means that if you get any value of x in this interval, okay, substitute it in the function, the outcome, okay, or the result that you need to get should be also a value that is within the interval. What I mean here is that, for example, if you get 2.5, you substitute in the function here, you shouldn't get something like 4 or 2. No, because 4 and 2 are not in the interval. You should get something that is between 2.5 and 3 as well. Okay, so what it means is that g of x must belong to that interval, 2.5 to 3. So we can check this. Let's check. So we can just pick these values here, right? The endpoint values, right? So let's substitute g of 2.5. This is 5 over 2.5 squared plus 2. So someone with a calculator, please do that calculation. Nobody has? Okay, may I have mine check if it's 2.8, right? And as you can see, does 2.8 belong to this interval? Someone to confirm? Does 2.8 belong to this interval? Hey, guys.
Yes, it does.
It does.
It does, right? Okay, because the values are starting from 2.5 to 3. So yes, 2.8 belongs to this interval, right? Let's also check 3. Let's check 3. So let's also substitute g of 3. Okay, 5 over 3 squared plus 2. So what do you get there?
2.555.
2.555, okay, 2.555, okay, or 56. Does this value belong to the given interval? Does it?
Yes, it does.
Okay, yes, it does. Okay, so this also belongs to the given interval. So it means that there is a possibility that even other values in between, they can also give you the same thing, right? Okay, so me, I like showing this. Let me just show this again to you that, okay, let me share this screen. Let's try to sketch this function also. Of course, we understand better when you sketch it. You see how it behaves, right? So if we go back to this sketching, this graph. Okay, let's say the function is given by y is equal to 5. Okay, 5 over x squared, right? 5 over x squared plus 2. Let's see. And then the interval is between 2, 5, and the what is the interval given? And 3, right? Okay, let's check if this function is continuous. Okay, I'm trying to zoom it in. Okay. So this is a sketch of that. As you can see, it has asymptote on the y-axis. Huh? This is an asymptote means that this function doesn't cross the y-axis, and also neither crosses the x-axis. This is an asymptote. Doesn't approach the x-axis. It approaches the x-axis just like that. Constant. Right? Okay. And you can see that y, it can't cross the y-axis. The reason being is that on the y-axis, x is equal to 0. And that function doesn't allow x equal to 0. The x is in the denominator there, so it can't be equal to 0. No wonder it goes to infinity as it is approaching the y-axis. Okay, now let's go back to the given interval. The given interval is 2.5 and 3. Okay, yes, here. So I've just zoomed it in. I'm sure I can see the 2.5, right? So this is 2.5. And then up to here, right? And then up to 3. So okay, so this function is continuous. Okay, what I mean is continuous. There's nothing like maybe there's an asymptote in between, or there's a hole, okay, or something, this function is actually continuous on this interval. That's what it means. Sketch it. Okay. And it also means that, okay, if I get any value within this interval here, okay, the interval of x from 2.5 to 3, I substitute in the function. I should also be able to get something that is within the interval, the y value. The y value I should get should be between what? Between 2.5 and 3. As you can see here, between 2.5 and 3, even the y values, look at them as well as they are changing. Have you seen changing the y values, right? Okay. When I'm at 2.5, the y value is 2.8, the one we found. Look at the corner, 2.5, 2.8, right? So when I'm at 2.5, the y value is 2.8. If I start moving along this interval, 2.5 to 3, as I'm approaching 3, you see that the y value is 2.7, 2. Whatever, 2.769, 2.67, 2.66, 2. Okay, everything, that's like that. And until we find the y value when the x go to 3, which is 2.55 that you guys found. So there is no value that is outside this interval. Whatever value of x substitute, it will give you the value of y, which is bounded within the interval. Do you guys understand? Hello?
Yes, we do understand.
Okay, so this is what it means. So if you get any value in this interval here from 2.5 to 3, the y value that you're going to get, or the function value, will be also within the interval, not beyond that. Okay. So check that condition. Now let's go back to our problem. So yes, so it is continuous, of course. It is also bounded within that interval. Yes, we've checked that. Now, finally, we also have to. The last condition is this. Okay, the derivative of the function, the absolute value of this function, must be less or equal to k, and this k value must be less than what? 1. This k value is the value that we get. Okay, what it means is that, okay, k value is a value that belongs to the interval. Of course, this k should belong to the interval. Okay, if you get the derivative of the function and then substitute any value in this interval, that value must be less than 1. Okay, so let's first get the derivative of the function here. So the function is g of x is equal to 5 over x squared plus 2, right? Now let us get the derivative of the function. Okay, so g prime of x, this is equal to what? Of course, this function can also be written as what? 5x to the power negative 2, right? Plus 2, isn't it? So this is in negative 10x to the power negative 3, right? This goes to 0. So I have 10 over x power 3. Now, what does this mean here? So from this condition, it says, okay, k value must be less than 1, right? So it means that now if I get any value that is within the interval, let me say get 2.5, okay? So g prime of 2.5, right? This, of course, is negative, but we're just interested in the absolute value, okay? So we're not interested in the what? In the sign, okay? So we have 10 over 2.5 to the power 3, negative, but we just need absolute of it. So check, is that value less than 1? Who was that lady who was punching? I think she was hoping. Now she's gone?
I'm still here.
Why? Have you stopped? Okay, so I'm getting 2.4, and this 2.4 is less than 1. You can also check the derivative of what? The function at what? At 3, right? Let's also check at 3. Let's see if we're getting 1. So we're going to have negative 10 over 3 to the power 3. And of course, this is 10 over 27, right? It's 1, isn't it? So 10 over 27, that is less than 1, of course. Okay, this is 0.37, and this is less than 1, of course. So there is a fixed point, and that fixed point, when this guy is satisfied, okay, this condition here, the fixed point is unique when there's that, this condition is met. Fixed point is unique. There is a fixed point, but that fixed point now is unique when this condition is met. Okay, so you can also check this. Math is better understandable when you see what we're talking about. Okay, so let me scale the derivative of that. I'm going to call it y also. Okay, the derivative of that is 10 over oh, sorry. Oh, okay. Yeah. This is 10 over x to the power 3. You just need the absolute of it. Okay. So from the interval of what? 0.5 to 3. So let's check. Is if you get any value in that interval. So I'm trying to, this is the function that I've sketched. This is the y-axis, this is the x-axis. This is how it looks, as you can see. Okay. It looks like this, and then also this side of this. But let's just focus on this side from 2.5 to 3, right? If you notice, from 2.5 to 3, this function, if you get any value of x, substituting the function, this is a value of x along the x-axis. I hope we are seeing. Then let's start at 2.5 itself. 2.5, substitute the value of x. At point, you see that we are getting the value of y is 0.64. We found this value, which is less than 1. And if we start substituting different values of y, okay, in the derivative, we see that all the values of, so different values of x for that derivative, in the derivative, we see that all the values of y we are getting, focus on the y value, the x value is not necessary. All the values of y we are getting are less than 1, 0.49, 0.47, 0.4, whatever. All those values are less than 1 until when you substitute 3. You see that when you substitute 3 again, we found this is 0.37 and this is also less than 1. Okay, as you can see, as we are moving along this interval, you see that y is always less than 1. That's what it means. Okay, I hope this is clear. People are so quiet, you can't confirm whether they're understanding or they are not.
It's clear.
Okay, so that is the case. Okay, so I've checked. Okay, it is there is a fixed point. Okay, so for the first question here, there is a fixed point. Let's look at the next question. So we're done with the first one, which is part A. Let's look at part B. Okay, part B. Let's see. So part B, we have g of x is equal to pi plus 0.5 sine of x over 2. So the interval is 0 to 2 pi. Okay, so again, we repeat this, right? So you see that this is a sine function, right? Sine functions are all continuous, okay? Sine functions are always continuous at every point, okay? Because you know the curve of sine function, it's always continuous everywhere, right? So as you can see, we have a sine function here, and this pi is just a constant. It don't have even any effect, right? So you can see that since we're doing a sine function, of course, we know that sine function is always continuous at all points, from negative infinity to positive infinity. Okay, this we know. It is wrong. Okay. So we know that sine x always, doesn't matter sine x, whatever over what, sine x over 2 is continuous on the given interval. Okay, from 0 to pi on the given interval. Okay, this interval from 0 to pi, it's continuous. Okay, because sine is continuous everywhere. You know that. Okay, there's no point where sine let's say you have a sine function, it starts, and then here it says, okay, no, I'm not going to continue, and then it jumps, it starts again, like that because there's an asymptote in between here. No, sine function is continuous throughout. So this one is very much obvious. Okay. Next thing we need to check also that, let's check this condition as well. What other condition are we supposed to check? This function g of x must belong to the given interval, right? Every time substitute any value of x in this interval, the output should be bounded within the interval. Okay, so let's check. So let's get 0. So we're going to have g of 0 is equal to pi plus 0.5 sine 0/2, right? So this is sine 0/2 is simply sine 0, which is just 0, you get a pi, right? So pi is within the interval, of course. Okay, from 0 to 2 pi, pi is still belongs to that interval. You can also check g of 2 pi. Okay, so pi plus 0.5. 0 and, okay, 0 and what? All these give you the same value. Let's check sine pi. Let's check pi. Okay, when you substitute 2 pi and 0 in sine function to give you the same result. Okay, because you're going to have sine what? You're going to have sine 2 pi over 2. 2 and 2 cancel out, you're going to end up with sine pi. And sine pi again is equal to 0. So you still have pi. So you can actually skip that. Let's even get random value of pi in between, right? Of the random value of x in between. You can pick pi. So g of pi, going to pick pi plus 0.5 sine pi over 2. So pi over 2 is simply sine pi over 2 is simply 1. So 1 plus 0.5. So pi plus 0.5. And you can check this. Pi plus 0.5 in decimals, put decimal numbers, you see that it will still belong to that interval. Okay, so this condition is it has passed this condition. Next, we need to check now the derivative g prime of x. Okay, let's check that. So the derivative of pi is simply 0. Okay, and then here we're going to have 0.5. The derivative of sine is simply cosine, right? You're going to have cosine of x over 2. By chain rule, we also have to differentiate x over 2, right? So multiply this by 1 over 2. Okay. The derivative of x over 2 is simply 1 over 2, isn't it? I'm just applying I'm applying chain rule here. So you have 1 over 4 cosine x over 2. Now let's check. Okay. For all the values, is this guy here, g prime of x, the absolute value of that less than or equal to k less than 1. Let's check this condition. So let's substitute value of x from the given interval here. So g prime of 0. So you are going to have what? 1 over 4 cosine. Please, let's mute our mics. Let us mute our mics. Okay, thank you so much for the. Okay, so cosine of 0 over 2. Okay. No, cosine of 0 is simply 1. So you get 1 over 4. And 1 over 4 is 0.25, right? And 0.25 is simply less than 1, as you can see. Okay, so this one has passed. Let's check. Okay, and you know that sine function is maximum at that point. There's no way it's going to give us something. You know, sine always produces 1, right? I mean, cosine function.
I have a question.
Maximum. Yes,
Sorry,
please.
before you go far. For the part where we were putting the intervals on the g pi, how come you put pi instead of 2 pi?
No. I said you can pick any value in between. I'm not restricting you to pick only the endpoint values, right? Okay.
Oh, okay.
So I
okay.
picked a pi. Pi is in between those two values. Because if I pick 2 pi, 0 and 2 pi, they give me the same result. They're both giving pi as of that value. So just okay. For diversity's sake, let me just pick pi. If I want, I can pick pi over 2, as long as within the interval. All of them must satisfy the condition.
Thank you.
Yes. So you see that if I put 0 here, no matter what value x, you are going to put this function. This cosine function is going to give you something between 0 and 1. That's all. So it means that, of course, this is true. Okay, this means that, oh, it's always less than 1 in this interval. And of course, just for the sake of you people visualizing, I'm going back to the graph. Let's get that graph, we'll see. So this graph is pi. Okay. Pi. Is this okay? Okay. Pi plus is going to give us something here. 0.5. Sine x. Oh, I don't think this will give us something. Let's check. No. Oh, it's giving us this value. And x over 2, right? X over 2. Okay. So it's loading. Let's wait for it. Okay, so it has plotted for us. Let's get the graph for us, which is it? Pi plus 0.5 sine x over 2. So as you can see, so the interval given for us is from 0 to 2 pi. What is 2 pi? Want to give me that in decimals? What is 2 pi in decimals? Hello? 6.2 something, right? We are only passing from 0 to, so from 0 here, okay, to something, right? Okay, yes, that's what we're focusing on. So let's zoom in from 0 to 6.28. Let's zoom in. Okay. So when x go to 0, let's find the value of what? The value of the function. So you see the value of the function, y-intercept a, it's about it. It's pi. As you can see, look at that coordinate given to us, 0, pi. And we found this, right? We said, okay, when x go to 0, we found out that, okay, f of 0 is pi. And this is a pi which is given to us, as you can see, it's 0, pi. And then as you're moving, okay, look at the values changing, right? So as you're moving along this curve, you see that the values of y you are getting as you're changing the values of 3 point something, 3.34, 3.37, 3.4, what? All those values are less than 2 pi. All those values are less than 2 pi. Okay? All those values are less than 2 pi, all of them less than 2 pi, until you reach where 6 something, the endpoint is 2 pi, right? The endpoint is 6.2 something, right? That's what we are told. 6.2 something here, okay, 6.28 value of x, which is 2 pi. So 2 pi is somewhere here, I don't know, just approximate it. But it's still, all the values of y we are getting, they are less than 2 pi itself. Okay, they are all less than 2 pi. So it's confirmed that, oh, okay, whatever value of x you are substituting this function, the value of y you are getting will be less than that, but will be within the interval. Is this clear?
So my network is bad. I've just joined, so I'm not clear on the part you've started with the derivatives going down. Hello,
Hello, yes, I can get you.
Yes, I'm saying on the part of the absolute value of that derivative going down. I'm not clear on that.
Okay, I was saying that the absolute value in that given interval must always be less than 1. So what you need to do, you get the derivative of the function. Okay, you get its derivative, which is this one here. And then next, you have to do what? You have to check that given interval. Okay, from 0 to pi. This function must always be less than 1. So I substituted 0. Okay, so substituting 0 in the derivative. Okay, it's giving me something less than 1. If I get any value of x, put in the derivative here, it will always be less than 1. The reason being is that cosine of whatever inside here, it will always give you the value between 0 and 1. And if you divide that value by 4, it will always be less than 1. So no matter what value put in this interval, it will always be less than 1. Okay? So that's a condition always you check. Okay, the derivative must be less than 1 in the given interval. I don't know if I'm making myself clear.
Yes, I'm clear.
Okay. So you can also confirm this graphically. You can sketch that function 1/4 cosine of x over 2. Okay, let's check. So you see that if we have to sketch this, okay, let's sketch it. It's 1/4 cosine of x. Okay, cosine of x over 2. This is the derivative we found, right? So that's a sketch of the derivative that we have. Okay. So you see that we are focusing on from 0 to pi. So 2 pi is 6 point something, right? So as you can see, this function, let me zoom it in. Okay. So you see that at x go to 0, the derivative is what? It's 1/4. And we found this 1/4 is 0.25. Okay, when you substitute x go to 0 in that derivative, and then we move along that curve, you see that all the time the values of y are less than 1. 0.19, 0.17, 0. Whatever, 0. Whatever, all this, and then at this point of 0. And 0 is less than 1, okay? And then we continue, okay? We continue all this until 2 pi. 2 pi is, at this point, this is 2 pi. 6 point something, right? And this one here is negative 1/4, but remember that we are getting the absolute value. We are not interested in the negative signs, and this is also less than 1. So as you are moving along this curve, you are always having your derivative less than 1. Okay? That's whole theory behind it. Okay? So you can check the rest. You can try the rest of the questions and confirm that. Okay? So I've left you with the 3 questions. Those 3 questions, try to practice them and see if you'll be able to. Hello?
What is that parameter K?
Sorry?
What does it represent? What does K represent?
K is just a number which is with which should be less than 1, okay? That K is it's a number which is supposed to be less than 1. You get it by substituting the value of x from the given interval. You are checking, okay? So in this case, our K is 0.25. That is our K. When you checked with what? 0. So in substituting 0, we are getting K is equal to 0.5. If you substitute any value from this interval, you're going to get another different value of K. So all those values of K must always be less than 1.
All right. Okay.
Yeah, so this K is the value you get when you substitute what? The values of x in the interval from the interval in the derivative. So those are values of K we're talking about.
So is it always that the intervals, the first one and the last one, when we plug in their values in our functions, will be less than 1? Is that the case always?
Which are you talking about, the derivative or the function? There are 2 cases. Remember that the first rule is that you have to check that it's continuous. Second, you have to check that, okay, the function given belongs to the given interval. And this means that if you get any value in the interval, you substitute in the function, the actual function before you differentiate it, you should get something within the interval. This is what we showed. We have shown it already, okay? When I picked 0, I substituted in the interval here, I got pi, okay, as my answer here. And pi is within the interval. I picked pi from the interval also, because I didn't want to pick 2 pi. 2 pi would also give me the same results of pi. So I just said, okay, let me try something different. So I picked pi from the interval, substituted it here. I got something pi plus 0.5. Pi plus 0.5 is a number that is also within the given interval. So this condition has been checked. And then next is the derivative condition, right? So we first get the derivative of the function. So the derivative of this function is simply this, 0.5 cosine of x over 2 times half, which is 1/4 cosine of x over 2. Okay. And then now this is a condition that you are showing something to be less than 1, okay? For all the values of x you're going to get from this interval, if you substitute them in this interval, you should get values of k that are less than 1. So I started with a 0. I picked a 0 here. I go to 0.25, which is 1/4, and 1/4 is simply less than 1. Okay. I can also pick another other value, right? Which other value can I pick from the interval? You can even pick, if you want, you can pick pi/2, you can pick whatever you want. All the values that you should choose here should give you something less than 1. Okay, so it's not that always that no, the last value and the starting value must also give you less than 1. It depends on the situation, right? If it's derivative, these values strictly must give you something less than 1. If you are checking for the this condition number 2, they should always be less than 1, but they should give you something that belongs to the same interval given, because this condition checks the interval. Okay, this condition here checks for the interval. So meaning f of x given f of x must belong to the given interval a comma b. This is what the condition states. But this one is for the derivative where g prime of x must be always less than 1. I don't know if that is clear.
Yes, that is clear. So in a case where the derivative of the absolute value of our function doesn't hold, where k must be less than 1, what's our conclusion?
Speak up, I can barely get you.
So in a case where the derivative of that absolute value function doesn't hold for k must be less than 1, what would be our conclusion?
The conclusion is that there is no unique fixed point. That's a conclusion.
All right, thank you.
Yes. Okay, so the time is up. Do we need to do one more session or we can end here? Oh no, I have something at 20 hours. So let me see. Because I don't think another session can take us up to, because maybe tomorrow and Tuesday we can finish this draw sheet. Okay, so I think let's meet tomorrow. I have something at 20 hours I need to do.
All right.
Yeah.
Thank
Thank
you.
you so much.